Today I am going to explain about the atomic structure, as a knowledge of chemistry is needed in every modern science from astronomy to zoology. Chemistry is the science that deals with the composition, structure, properties of the matter and the changes that matter undergoes. Matter is anything that occupies space. Water, gold, rocks, buildings and people are matter. All the matter that you are likely to meet in your everyday life is made up of chemicals. Why atomic structure is a part of general chemistry? As all properties of matter depend upon atomic structure that provide the answers to such questions like why does sodium react vigorously with water, whereas gold coin in sunken ships can be recovered in good condition after 100 years in water. A knowledge of atomic structure will help you to understand why substances behave in different ways. My lecture plan today's will be focused on fundamental particle of atom, discovery of nucleus, electromagnetic radiations or waves, quantum theory of radiation, photoelectric effect. In 1807, John Dalton proposed his famous atomic theory. According to Dalton, matter is composed of very small particles called atoms. They are invisible. However, the study of conduction of electricity through gases, development of radioactivity etc. provided a number of evidences which exhibit that atom is not invisible but consists of three main fundamental particles called electrons, protons and neutrons, fundamental particles of atom. William Crookes in 1879 observed purple glow when electricity is passed in a discharge tube at 0.01 mm mercury pressure and 10,000 volt. He called it cathode rays due to coming from the cathode. These rays or the characteristics of these rays, they move in a straight line, possess considerable momentum, deflected by electric and magnetic field. These can cause many substances to fluorescence. J. Thomson in 1897 extended these investigations and determined the velocity and charge upon mass ratio of these particles and found the value 1.75875 into 10 raised to the power 11 C per kg. Since the value of E by m was obtained same irrespective of the nature of metal used as cathode and the nature of the gas filled in discharge tube, hence it was suggested that negatively charged particles constituting the cathode rays be called as electrons. These are fundamental constituents of matter. The mass m is equal to E upon E by m has been can be calculated by this equation, and by these figures it will be equivalent to 9.1091 into 10 raised to the power minus 31 kg. Goldstein in 1886 used perforated cathode in the discharge tube. The discharge tube generates not only electrons but also positive ions at the same time. These positive ions can be removed as a beam, which are known as anode rays or positive rays, and by studying their behavior in electric and magnetic field, their charge and mass can be measured. J. Thomson in 1910 measured the E upon m ratio value for positive rays and found that the value was not constant. It varied with the residual gas in the tube. In the case of hydrogen electron, E by m value was found to be largest or positive rays, and by studying their behavior in atomic and magnetic field, their charges and masses can be measured. This value was approximately 1 upon 1837 of the E by m value of electron, that is 9.79 into 10 raised to the power 7 charge per kg, and the charge E is found to be 1.60206 into 10 raised to the power minus 19 charge in case of hydrogen. The positive charge particle obtained from hydrogen gas is called proton, as suggested by Rutherford. This hydrogen atom, when eject the one electron, it becomes positively charged, called proton. For proton, m is equal to E upon E by m is equal to 1.6735 into 10 raised to the power minus 27 kg. Chadwick in 1932 discovered neutron, a neutral particle, by the bombardment of alpha particle on beryllium. As it has been shown in this equation, when the beryllium is bombarded with the helium alpha particle, then it is converted into carbon and the neutron is ejected. The mass of the neutron is equal to 1.6735 into 10 raised to the power minus 27 kg. In this table, the characteristics of fundamental particle shown here likewise. The particle proton symbol is P. The rest mass of the proton in kg is equal to 1.6735 into 10 raised to the power 27, and the atomic mass unit is equal to 1.007276, and the charge will be of this value. In the case of neutron, the symbol N, and the rest mass in kg is this, and the atomic mass unit is this. The charge is nothing on the neutron as it is neutral, and the electron E, symbol E, and the rest mass in kg is this value, and the atomic mass unit is this value, and the charge on the electron is this value. Rutherford in 1911 performed experiments on scattering of alpha particles by thin metal, gold, aluminium, etc. foil. By calculating the magnitude of scattering of alpha particle as a function of the atomic charge, it is found that the n phi is equal to n0 e to the power minus phi upon phi m whole square, where n phi is the number of particles scattered at an angle phi, n0 is the total number of incident particles, and phi m is the most probable angle of the scattering. On the basis of the observations made in the scattering experiments, Rutherford concluded that atom contains a heavy and positively charged body, as its center known as nucleus. The size of the nucleus is very small as compared to the atom. The nucleus has diameter of the order of 10 raised to the power minus 15 meter, while that of the atom of 10 raised to the power minus 10 meter. Atom consists of lot of empty space around the nucleus. The electrons are revolving with a fast speed around the nucleus, and almost all the space around the nucleus is occupied by the revolving electron. Since this model of atom resembles with the solar system, hence the electrons are also referred to as planetary electrons. There is one very serious drawback in Rutherford's nucleus atomic model. According to classical electromagnetic theory, if charged particles like electrons moves around the oppositely charged particles like nucleus, the moving particles would continuously lose or radiate energy, and its speed will decrease and come closer to the oppositely charged particles by a spiral path. It means the electrons will fall into the nucleus, thereby making the atom unstable. This dilemma was solved by Niels Bohr in 1913. Simultaneously, Moseley in 1913 studied the wavelength of the characteristic X-rays using different metals as anti-cathode. He postulated that square root of the frequency nu of the X-ray is directly proportional to atomic number Z. So, this equation is given like this, that square root of nu is equal to a Z minus B, where A and B are constant. The atomic number is a fundamental property of the element and equal to the number of protons in the nucleus, that is equal to unit positive charge on the nucleus. The sum of the number of proton and the neutrons in a nucleus is called mass number A of the atom. So, A that can be expressed A is equal to N plus Z. Now, I will discuss the electromagnetic radiations or the waves. J. C. Maxwell in 1864 suggested that radiant energies, the energy which is radiated such as light, heat, X-rays etc., travel in a space with the velocity of light 3.0 into 10 raised to the power 8 meter per second in the form of the waves. These waves are known as electromagnetic radiations or waves. Wavelength, which is denoted by lambda. The distance between two nearest crests or troughs is known as wavelength. It is expressed in centimeter or nanometers or in angstrom units. The equation can be written like this: 1 angstrom is equal to 10 raised to the power minus 1 nanometer is equal to that equivalent to 10 raised to the power minus 8 centimeter or equivalent to 10 raised to the power minus 10 meter. This is the wave which can be shown like this, that it is the crest of the wave, it is the trough of the wave, and the distance between the two is denoted by the lambda. Now, I will discuss about the frequency. The number of times a wave passes through a given point in 1 second is known as the frequency of the wave. It is expressed in the hertz or CPS, cycles per second unit. So, 1 hertz is equal to 1 cycle per second. Now, I will discuss the velocity c. velocity, which is denoted by c. The distance travelled by the wave in 1 second is known as velocity of the wave. It is expressed in meter per second and related to nu and lambda as follows. C is equal to nu lambda or nu is equal to c by lambda. Now, the wave number, which is denoted by nu bar, it is reciprocal of the wavelength, that is the number of wavelengths per meter, which can be given in this equation. Nu bar is equal to 1 upon lambda per meter, or we can write nu bar nu upon this, refer to the equation 3 as given above. I discuss about the amplitude. What do you mean by amplitude? It is the height of the crest or depth of the trough of the wave. It determines the intensity, that is brightness of the beam of light. As we are discussing about the electromagnetic radiations or waves, so it is important to know when the different electromagnetic radiations are arranged in order of their increasing or decreasing order of wavelength of the frequency. The pattern so obtained is called electromagnetic spectrum. Now, I will discuss about the quantum theory of radiation. Max Planck 1901 studied the energy of radiations emitted from hot black bodies and proposed a theory which is known as quantum theory of radiations. Einstein in 1905 extended this theory, and according to this theory, the radiation energy such as light or heat is not emitted or absorbed continuously, but discontinuously in the form of tiny packet of bundles or energy known as quanta. Each tiny packet of bundle or energy, or known as quantum, is called photon, which is considered to be massless. The energy of each photon of emitted light is proportional to the frequency of the radiated light, which can be expressed in this E is directly proportional to nu or E is equal to h nu, where h is the Planck's constant. Its numerical value is 6.626 into 10 raised to the power minus 34 joules per second in SI units, or 6.626 into 10 raised to the power minus 27 ergs in CGS unit. The body can emit or absorb energy in whole number multiples of quantum that can be expressed E is equal to n h nu, where n is integer 1, 2 or 3. This is known as quantization of energy. Since nu is equal to c by lambda and 1 upon lambda is equal to nu bar, hence E is equal to h nu may be written as E is equal to hc upon lambda is equal to hc into nu bar, where c is the velocity of radiation in meter per second, lambda is wavelength in meter, and nu is wave number in per meter. Some important features of the electromagnetic spectrum given in this table. Electromagnetic radiations are radio waves, microwaves, infrared rays, visible rays like this, and their wavelength in angstrom is 3 in like radio waves comprising of 3 into 10 raised to the power 13 to 3 into 10 raised to the power 9 angstrom. Their frequency 1 into 10 raised to the power 5 to 1 into 10 raised to the power 9. Their energy in kilojoules per mole is 3.99 into 10 raised to the power minus 8. While microwaves, they possess the wavelength from this range to this range in angstrom, their frequency from this range to this range, and their energy in kilojoules per mole is 3.99 into 10 raised to the power minus 4. In the same way, the infrared, they are also comprising of the wavelength in angstrom from this range to this range, and the frequency from this range to this range in hertz, and the energy in kilojoules 1.99 into 10 raised to the power minus 1. While the visible rays, they are comprising of the wavelength from this range to this range in angstrom, and the frequency from this range to this range in hertz, and their energy has been calculated 1.58 into 10 raised to the power 2. Ultraviolet rays, they comprise wavelength in angstrom from this range to this range, and the frequency in hertz from this range to this range, and while the energy that has been calculated 3.16 into 10 raised to the power 2. Likewise, the X-rays, gamma rays and cosmic rays, they are having the wavelength in this, the X-rays having this range, and the frequency in hertz in this range, and their energy in kilojoules per mole like this, and the gamma rays, they have the wavelength in this in angstrom from this range to this range, and frequency from this range to this range in hertz, and their energy in kilojoules per mole. In the same way, the cosmic rays, they are having the wavelength from 0.001 to 0, and the frequency in hertz, that is 3 into 10 raised to the power 21 to infinite, and the energy of 1.2 into 10 raised to the power 9. Now, I will discuss about the photoelectric effect. J. Thomson observed that when light of a certain frequency or wavelength strikes on the surface of the metal, the electrons are ejected or emitted from the surface of the metal. The phenomenon of ejection of electron from the surface of the metal when light of a suitable frequency strikes on it is known as photoelectric effect. The ejected electrons are known as photoelectrons. This effect is governed by the following laws. Number 1 is the photoelectric effect is more pronounced in alkali metals due to low ionization potential. Only those radiations which have a certain minimum value of frequency, that is threshold frequency nu 0, can eject the electrons. The value of nu 0 is different for different metals. The number of photoelectrons ejected is directly proportional to the intensity of the incident light. The magnitude of kinetic energy, velocity of the photoelectron increases with increase in the magnitude of the frequency of incident radiation above the threshold frequency. Wave theory of the light cannot explain the photoelectric effect, because according to this theory, energy of the light depends on its intensity. Therefore, light of any frequency, if made sufficient intense, can cause ejection of the electron, whereas this do not happen. To explain the photoelectric effect, Einstein in 1905 proposed a theory based on Planck's quantum theory of radiation. According to this theory, light consist of bundles of energy called quantas or photons. The energy of each photon being equal to h nu, where nu is the frequency of light and h is the Planck's constant. When a photon of energy h nu strikes the metal surface, its energy will be consumed in two ways. Number one, a part of its energy is used to remove electron from the metal surface, which depends upon nature of the metal and is called work function psi 0. The remaining part of the energy is used in imparting kinetic energy half mv square to the photoelectron. Therefore, we can express this in the form of this equation h nu is equal to work function phi 0 plus half mv square is equal to h nu 0 plus half mv square. Since work function phi 0 is equal to h nu 0, hence half mv square is equal to h nu minus nu 0. This equation is known as Einstein's photoelectric equation. With this, I conclude this today's lecture, as I have discussed about the fundamentals and the basics of the atomic structure. Without knowing about the basics of the atom and its structure, one cannot explain rest of the reactions in the chemistry and cannot understand rest of the things. Thus, I conclude over here this, and the next lecture will be on the Bohr's principle, Bohr's theory